Welcome everybody to Chuks Forge 0.0.8, right? This is the first ever um, webinar we're going to be holding for Chuks Forge. And this webinar is just to kind of show everyone what my friend here has been building. That's Chukwemeka for the past 5 years. A programming language that takes a philosophical approach to solving most of the constraints and problem that we have right now. So as the name says, Chuks Forge, that's the name of the programming language. So we're going to be looking at a lot of things. We are going to be looking at what is this Chuks Forge, right? What is it? Why do we need it? Why did we commit, or why did he commit so much time and effort building this? What kind of problem is this solution solving, right? And how do we use it, or how do we apply it to our daily life? So this is just meant to be an introduction that will talk about the reason behind the initiative and what the frontier for Chuks Forge is going to be. So I want to implore us to kind of listen, sit back, and grab what we can grab. So it's not kind of like a know-it-all webinar where everybody's coming here to claim that we know it all. No, it's just to show you people. So you people are the audience. You people are the potential users. You're the ones that will use it, right? And we want to run this initiative by you. And we expect that there are going to be questions, there are going to be opinions, as regards Chuks, right? So I would want to hand over to Chukwemeka with behind choose. Please, as he's speaking, if you have questions, kindly note your questions down, or you can send it to me or drop it in the chat sessions. I will pick and compile those questions. Then when we get to the interactive sessions, then we can now start deliberating on your question. Chukwemeka, you have the floor. Thank you.
All right. Hi everyone. I'm happy to have you all here. My name is Chukwemeka Ibokwe, and working on Chuks for quite some time. And today, we'll be sharing some information or details about Chuks programming language. I mean, the question is, what is exactly is Chuks programming language? Right. So Chuks is a modern programming language that is simple to learn and fast to run. Is very, very much expressive enough for real world applications, right? And is a general purpose statically typed programming language with a very clean and readable syntax, more especially if you are coming from the likes of TypeScript, Golang, Java, C Sharp, right? You'll really find the syntax really welcoming, right? Everything in Chuks ships with 1-2 chain. You have the VM, which is on the bytecode level, and the ahead of time compiler, right? And it also has built-in high performance HTTP runtime with native concurrency and a very rich standard library, right? So the idea there is, you build it once and you ship it as one single contained binary, right? You don't need to install any external dependency, just as you do in other programming languages like the likes of Java or even Node.js, right? Python and the likes. And the vision is having one language for both your backend scripting and data engineering, right? Without switching in between languages. For people coming from the data background, you build your model or you build whatever you have on Python, and if you want to serve it, you either go for faster You either go for the likes of Golang or Rust, right? But the idea of Chuks is using one language to build everything, right? Because Chuks is extremely fast. Productivity like a scripting language, but fast like a compiled one, right? So you run the same file, the same script, Chuks file, both in your VM during development, and when trying to push for production, you ship it as a single binary, right? So Chuks compiles down to a single binary, right? The deployment is extremely easy. Drop in the binary and just run it, right? You don't need Docker. You don't need if it's in Node.js application, you need to install the packages that you need. You don't need that with Chuks. Everything in Chuks compiles to a single binary, right? So um, on the philosophy, like I mentioned, is very simple. The syntax is very simple and easy to understand, right? There is no boilerplate ceremony. It's extremely fast because it compiles down to native binary, right? And performance is default in Chuks, right? In other languages, you need to optimize your code for you to achieve performance. Do you get? Imagine you write your .NET app or Java, or maybe if you are doing Node.js, right, or even Python. For you to achieve a certain level of performance, you need to optimize your code, right? But that doesn't really happen in Chuks. Chuks is optimized by default, right? The compiler and the type checker guides you to write a very much more performant code, right? And is multi-threaded. The syntax, like I mentioned, is expressive, right? We have classes, interface, generics. Functions are first class. For concurrency, we have the async and wait. We have also the spawn. We have channels for dealing with parallel computing, right? Then it also comes with batteries included, the HTTP server, the JSON, the OS, the maths database. By default, it has a database layer built inside of it, the likes of Postgres, MySQL, Microsoft SQL Server, Oracle, right? So those four databases are kind of built, is inbuilt, so you don't need to even reach out to external libraries to handle that. And it's saved by default, right? Because it compiles down to native binary, and the type checker is smart enough to guide you to write much more secured code, right? So Chuks is saved by default. We have the explicit nullability, whereby if you want an item or an attribute to be null at some point, you can add the question mark in front of the type. Or if maybe you don't even know the type that you are working with at a particular time, you can option in using option out using the any type, right? Then the next question should be, what exactly are the problems that Chuks solves, right? So one is the two language problem, right? Most people write a prototype in Python and later write it in maybe Go or Rust. And there is this saying that, if you want to build something really fast, like a startup, you just want to prototype on a product, you use Node.js, right? TypeScript, just write it. But when you start hitting millions of users, you start thinking of maybe writing them in Java, .NET, Go, Rust, right? So with Chuks, you don't need to do that because Chuks is extremely fast. So, and it gives you that developer experience you get from a scripting language, right? The next is based on dependency. Most programming languages, for you to do a particular thing, you need to install a lot of dependency, right? But That's not the case with Chuks, right? By default, Chuks ships with the things 90% of or 92% of the things you need to build a backend system, right? Because I mean, me, I'm also a backend engineer. I understand the things that is actually needed whenever you're building a backend system. You need a route, you need a HTTP server, you need database, you need middlewares, all those things. So there is no point kind of pushing those things to external libraries or dependencies, right? So all those things are inbuilt inside Chuks. So with just your Chuks installed in your system, you can build high level backend systems immediately. The deployment is extremely easy. Like I said, it compiles down to a single binary. Just drop it in and call it, right? It runs. You don't need to start installing lots of for Node, the Node models, JVM, Pythons. They have lots of dependencies that you need to install. That's not really the case with Chuks, right? And the choice between safety and speed of writing, right? Most fast languages, especially Rust, right? I don't know how many of you do Rust here, right? The learning curve is painful, right? If you're also coming from Golang, still the same thing, right? So we always have these two sides that if you want to work with the so-called fast programming languages, you need to go through that pain of knowing how memory works, pointers, boundaries and all this stuff. But if you just want to build something really fast, you can just use the lower end languages. But that's not really the case with Chuks. Chuks gives you both, right? Program as a scripting language and gain the performance as the high level languages like Rust and Go. Next is why you should care, which is very, very much important, right? One is, you write less code. You don't need to kind of split your code in between different languages. Write it once in Chuks and run it everywhere. It has a clean syntax, generics, async and wait, spawn, a rich standard library, right, that handles the common use cases that you ever have as a backend engineer, and also a data engineer, right? You can prototype really fast using the VM. You can really iterate, through your idea or whatever you want to build, and once you are okay with it, you can compile it down to a single binary, right? And the binary is portable, right? Consumes less memory, right? And the good thing is that you are early. This is one of the first Chuks Forge that we are hosting. The previous one that we hosted was on the release for version 007, right? So this is kind of, and that one was Chuks release Forge, right? But this is the very first Chuks Forge, that event that we are doing, right? So this is a good time to also influence the language, direction, and the packages and the tools, right? And next on my list is, we diving into the core concept of Chuks, right? The basics of the Chuks syntax, the types, classes, generics, async, how Chuks runs your code, both on the VM level and on the ahead of time compiler level, right? The models and the import system. And then we can do a walkthrough from a hello world to building a HTTP server with an endpoint, right? So before I continue, any questions?
If there are questions, you can maybe drop it on the chat.
Looking at this syntax here, I mean, is anybody who is a software engineer, let me not even say coming from a particular language, understands, the syntax we have here, right? We have a variable name of type string, and we assigned Alice to it. Then we also have another variable of age of type integer, and we assigned 30 to it. Then we have active, which is of type boolean, bool. We assign true to it. Then we have a constant of pi, which is a float. Then we assigned the value to it. Then on the lower part, we have var greeting equal to hi, and the hi is a string. So automatically Chuks will infer the type and set the greetings to of type string, right? Now, next is creating your first hello Chuks, like I just mentioned, right? Familiar syntax coming from TypeScript, Go, C#, Java, right? You can easily understand this. This is a main function that returns nothing, so the return type is void. Then you can print hello Chuks, right? To run this in the VM level, you just do chuks run hello.chuks, right? To run it to build it to native binary and run, you do chuks build hello.chuks, right? So same code running on your VM mode and also on the binary mode. Next is variables and types, right? So Chuks has var and const, right? Those coming from JavaScript, you have let and const, right? So in Chuks, you have the var and const with explicit type annotation, right? So in Chuks, because it's statically typed, you need to state the type of whatever variable that you are working with, right? The primitive types, we have the integer, float, string, boolean. We also have some other types on the integer level, like the signed and unsigned integer 32, 64. So you can also look up on the data types in the website to see all the data types that Chuks support, but these are kind of the fundamentals, the basics, right? We also have the collections, array of any type or a map. Then the nullable types are the ones that you specify the type, then you have a question mark at the front, right? So looking at the way I kind of designed the language, in the sense that it's very, very easy to read, like a normal sentence. Like if I say, how are you? How are you is a question, right? After my sentence, I add a question mark at the end of the sentence. So that's the same philosophy we used here, right? The string, then a question mark, right? Now, if you are pronouncing, let's say, array of string, array of object, array of this, you mention the array first before whatever that comes with it, like array of string. So that's the same philosophy we used here, right? So the square bracket is for array, right? And the T is the type. So you can have, just as we have here, fruits, array of string. You have array of string, array of any type that you want to work with, right? So looking at the in the right hand side, you have a variable of type string, you have age of type integer, active of type boolean, pi of type float, fruits of type array of string, right? Event as a map. So the type in the square bracket is the key, type of the key, and this other one is the type of the value. So this is a map of type key string, value string, right? And we also have the inferred types. Next is declaring functions in Chuks, right? Is pretty much more clean and easy. You can declare your function using the function keyword. So this is function add, which accepts these parameters: A of type integer, B of also of type integer. You calculate and specify the return type, right? You can also pass a function as an input, right? So function apply x of type integer, fn of type function, which accepts an integer and return an integer, right? And this apply function also returns an integer, right? So using functions in Chuks is pretty much more easy, just the way you also do it in other languages that supports both functional programming and object-oriented programming. Right, so next is classes and generics, right? You can pretty much create your class, group or organize your code in classes if you are coming from the OOP level, right? Then you can also create generics, passing the generic type to a class, just as we have it here. We have a class of box which accepts a generic type of T. Chuks also supports the access modifiers, which are the private, public, and protected. You just, the basic and the complete OOP functionalities is first class citizen in Chuks. You have your public private members, you have inheritance, interfaces, and the likes, right? Generics is also supported. Method overrides are, supported using the override keyword, right? Next is data type, right? For those coming from the background of .NET, C#, Java, right? I think Node.js has a record type too, right? Golang, Rust, they have struct. So in Chuks, because we also support records, we have a type called data type, right? The name data type is because Chuks is not just positioning itself as a backend programming language, right? It's also building the features for data engineering, the likes of data science, machine learning, right, AI, and stuff like that. So data type is one of the very important types in Chuks, right? If you are coming from the backend engineer perspective, you can use data type for things like your DTOs, right? API payloads and configuration shapes of maybe a class, right? And another good thing about data type is that it supports validation by default, right? You can also check that out on the website, right? So data type is just a way for you to declare or define the structure of whatever data that you are working with, right? So over here we have a data type of user, which has the following: ID of type integer, name of type string, email of type string with nullable. So this means the email can be there or not there, right? Nullable. And this is how to use it. So when you create your data type user, you declare your variable, and assign the data type to the variable, right? And now passing the actual data, right, to it. So that is it for data type. Next is concurrency, right? So by default, Chuks is multi-threaded. Chuks supports structured concurrency, right? And it also supports parallel execution, right? So for concurrency, we have the async and wait, right? Whereby you can create an async function and call it while awaiting for the response. You can also decide to push create a background job that you want to be executed in a separate thread, right? So you can do that using the spawn keyword, right? And you can also decide to, so this is more like a fire and forget, just spawn it, it goes in the in a different thread and executes, right? You don't need the response, right? But if you need the response, you can also await a spawn, and just the way you do your normal async await, you can also await it and get the response, right? Then we also have the channel for handling data communication between different processes, right? So imagine you have you are doing more like a parallel computing, whereby different or the same tasks is being splitted and executed in different threads, but you need a way to kind of collect the response of each of the process, right? So to do that, you use channels to do that. So you create a channel, and inside each of the parallel executing, methods, class, or functions, you can either send the response, channel.send, right? And once you are done, you just call channel.receive, and you get the response of whatever you've kind of collected in all those processes, right? Which is a very powerful tool for parallel computing and also concurrency. And the next is building a HTTP server in Chuks. It's very clean, it's very easy, it's very straightforward. From the standard library, you import create server via the HTTP, and also in Chuks, anything coming from the standard library has this STD in front of it, and also anything coming from the package registry. Of course, we can't bake everything inside the compiler, so all the packages that will be coming from the package registry will have the PKG in front of it, so that at a glance you know that, okay, this package is from the standard library, this package is from the package registry, right? And unlike the way we have it in Node.js, that everything just comes in under the hood, Node.js will first of all run a quick scan on your node models to know if that package is coming from your node model or is coming from your code, right? Because we want every milliseconds counts in Chuks, because we want it to be extremely fast, we just added the PKG so that the compiler doesn't really need to waste time checking your Chuks packages to know if that package is coming from the package registry or from your code. So once you have the PKG, it just goes straight to your Chuks packages and pull it. If you have the standard library, it looks it up internally. Then any other thing, right? Any other thing now comes in as being part of your code, right? So once you create a server, you pass it to a variable and you are good to go, right? This create server also accepts configurations, which we can also look up in the website to see all the configurations that is available, right? So you just have create your endpoint, server.get, right, passing the callback function, and that is it. Over here, server.listen to a particular port, and this is a very, very high performance HTTP server. The server can also handle middlewares, route grouping, and all those things, right? So you see that it's very, very easy for you to do all those things, compared to probably if you're coming from Node.js. For you to do this, you need to either import Express or Fastify or any other package. Something if you're coming from Python, right? So Chuks kind of cuts out all those dependencies, because one is built for backend and data, right? So some of those things that you need as a backend engineer and also as a data engineer is already built in, right? and everything is already in the binary form, so it's extremely fast. Now, the next is on the next and also the last in my list is how does Chuks differ from other programming languages, right? So with the walkthrough we've seen, you can see that when it comes to the syntax, it's very clean, it's very concise, and comparing it with other languages, you can see that Python also has that flavor. Node.js, Born, Java, there's a lot of boilerplates, and Go is not really that friendly. And Chuks, from what we've seen, you can see that the syntax is very, very clean and friendly, right? When it comes to static type checking, right, Python doesn't really offer that. Node.js and Born offers that via TypeScript, and which is still not 100%. Java offers that, Go offers that, and Chuks also offers that, right? When it comes to single binary deployment, only Go and Chuks in this list offers that. We also have Rust. Maybe in the next meetup, we can add more languages like C Sharp, Rust, right? And yeah, so we also have Rust when it comes to single binary deployment. Now, classes and OOP, Python does that, Node.js does that, same thing with Born, Java. Go doesn't really do OOP, right? But there is a way that you can, do OOP kind of in Go, but it's not really clean and straightforward. Chuks does OOP, right? When it comes to generics, Python does that. Node and Born doesn't really do that. You can only handle that via TypeScript. And we all know what happens when your TypeScript compiles down to JavaScript. All those types are gone, right? Java does that, Go does that, and Chuks also does that. When it comes to async await, Python does that, Node.js, Born does that. Java is not really that clean. They have all this completable feature and stuff like that, which is a nightmare. Go doesn't do that. Chuks does that. When it comes to structured concurrency, none of the languages in this list does that. Go kind of gives it to you, and you need to manage it, right? Else, you have a lot of errors. But Chuks handles it by default, right? So structured concurrency, how it works is, let's say you pass a request, right? And that request calls another asynchronous task or other subtasks, right? But in between that request being processing, you kind of terminate the request, right? So what happens? You've terminated the request, but what happens to other subtasks that is being created via that request, right? In Python, all those smaller tags, they will be ghosted. They will be there eating up your memory. They will be there running because they are totally disconnected from the primary request that created them. Same thing with Node.js, Born, right? Same thing with Java. I even thought that the new release of Java, they will fix that, but unfortunately they didn't, right? In Go, you will need to handle it by yourself. You need to write a code that will track all those sub processes and cancel it. But in Chuks is there by default. Once the primary request is being cancelled, every other sub processes that is being created is automatically cancelled, right? So Chuks handles structured concurrency end to end for you, right? Now the next is execution mode. Chuks has dual execution mode, the VM and the ahead of time mode, right? And the last is built-in HTTP server, right? Python doesn't have that. Node.js and Born has that. Java doesn't have that. Go has that, and Chuks also has that, right? So these are some of the ways Chuks is different from other languages. We also have the performance benchmark, which you can always look out in the website, right? So I think I'll hand over to David to continue.
Okay. That was great. I believe it's looking like for everybody now, it's looking like information load. But we are going to still break it down, and I'm going to do a very short run through the Chuks language and a bit of benchmark for us to see all what Emeka has said in context. Right? I think visualization speaks more than representation. But before we do that, Emeka, we have some questions here on the chat.
Okay.
And it's from Taiwo. And I think the first question is, I saw examples of variable initialization, but didn't see an example of variable declaration. Right. So I think he's trying to ask, is there a difference between initialization and declaration in terms of variable for Chuks?
Yeah, so in Chuks, once you create a variable, you must initialize it. The reason for that is Chuks doesn't really is saved by default. So the things like null pointer exceptions, undefined, all those things that you face in the likes of Node.js, Java. Null pointer exception is one of the things killing Java, right? So we kind of made it strict that once you create a function, right, you must instantiate it. You must pass, even if it's a default value to it. Do you get? So that Chuks will know that, okay, even if there's nothing, this function, this variable is empty, right? It has the default value. Yeah, Taiwo.
Sorry, is this allowed? Can I ask questions on questions?
Yeah,
Sorry. Yeah, answer to what you just spoke. Okay, I'm just going to skip the other questions because the answer you gave to this one kind of like spur another question for me,
Okay.
right? Which is during the presentation, right? Aside from how variables were being declared and initialized, you also talked about null handling, right? Variables can be declared with null safety, which is the question mark, right? Now, if a variable can be declared with null safety, but then the system expects that the declaration of a variable should also be initialized at the same time, I'm trying to wrap my head around how that is not negating each other. So yes.
Okay, so let me answer you. I think Paul is also raising his hand. So once you declare a variable, right, and give it a type of any type and add a question mark to it, right? So let me just go back to, okay, let's look at this. Imagine this is just a variable email of type string, and you have a question mark to it, right? You need to assign it null, right? So once you do that, if you are using this variable in your code, right, you must check if it's null. The type checker will enforce that you check that if this variable is null, right, you need to handle it. Do you get? It's not like other languages that you just, okay, this can be null or a particular value, and you just go straight and program. No. Then at the end of the day, everything will blow up. You will be getting undefined. You are trying to access an item in an undefined variable, things like that. No, Chuks doesn't support that. So if any variable or any data can accept a null, whereby you have the question mark, the type checker and the compiler will enforce that you will handle that null section of it. So if email is not null, you can say return an error. Email is required, something like that. Then you continue.
I believe that answers your question, Taiwo. Okay, great. Okay. So it's not trying to restrict you. It's trying to enforce accountability.
Exactly.
So also it's a way to actually manage memory space, because what we notice with the conventional language is like it gets to a point whereby you write codes and you're just killing memory. Even when you say you're optimizing, you're killing memory and the rest. But Chuks actually forces you to be accountable. So it's not saying that you can't define a value as null, but it makes you conscious of the fact that in your code before you get to runtime, in your compile time, it checks and see if there's anything that is null, right, that was not instantiated, and forces you to make a decision on how you want to handle that particular scenario, rather than it failing you during runtime. Okay, let's go to Paul. Paul, you have the floor.
Yeah, good afternoon.
Good afternoon.
Yeah, Mr. Kudos. I am impressed with what I've seen so far. But I have it's not really a question. It could be like concern and a clarity. I'm an node engineer. I use virtually all programming language. I want to speak to the concurrency because this is where most of these programming language are lagging. Java, React, JavaScript, any type of programming language is lacking in this aspect of the concurrency. Java is even out completely. And I see you mentioning SPAO when you SPAO processes. And you try to do process broker, message broker, where process and process can communicate, which for me, I think is a good one because I'm coming from the area of Alexa. I use Alexa a lot.
Okay.
But I have a question. The question is, maybe you should put a clarity on how this process talks together. How do you route process 1 to talk to process 2? You must have a router. And how do you do this router across different nodes that are not tied together in terms of multiple systems talk to each other, whereby you have one process on one server that wants to talk to another process on another server? How do they communicate? Because I've seen this challenge play out in Alexa, where I have to use RPC for the process-to-process communication. And it's a lot of problem for process to talk through RPC, which can be blocked by your firewalls and all that. So do you have that kind of model on Chuks where process to process can talk across a remote connection, not local, but remote connection?
Yeah, so I think we are pointing towards service-to-service communication, right? And we have different tools or different ways to handle that, because you can use RPC, gRPC, you can use Kafka. There's a lot of tools for that, Redis, right? So when it comes to service communication, right, each services is kind of decoupled from each other, right? And I think the job of each of the services is to hands or transfer data or push or communicate data to the other service, right? While the other one carries on with it. And there are different models to that. You can do the fire and forget approach, whereby you just push it and you continue with what you are doing. And if you want also to handle retries, there are different brokers that does that. Google PubSub is very good with that. And you can also
my question, do you have something out of the box?
No, so
that using third party because RPC is a third party communication model which is open.
Yeah.
What I'm asking, those Chuks act internal built in for this communication where I don't need to bug my head, I just need to do the setup and everything communicates?
Yeah, so RPC comes on the package level. Like I said, we can't build everything on the inside the compiler, right? So RPC comes in the package, which is still under development. But I think I need to share more light on that. When it comes to RPC, the way Chuks RPC works is very, very smooth and easy. You know, in other languages, for you to do things like RPC, you need to create your proto buffer and all those stuff, right? But in Chuks, you don't need to do that. Creating proto buffers are hell. Imagine in a very large system, you need to, writing all those things is time consuming, is draining. But in Chuks, you don't need to do that, because Chuks is statically typed, right? And that is where you see the full power of data type, this data type that we have on the screen, right? So once you define your data type can also serve as a proto buffer in Chuks, right? Because once Chuks RPC sees the data type, it understands the data, the structure of the data that you wish to pass through, and handles that for you. So building using Chuks RPC in Chuks is extremely easy and fun to do. So RPC comes on the package. Once the package registry for Chuks is in the final testing phase, right? We are testing it end to end to make sure that is very much more secured, because security, aside from you writing a very secured code, security is one of the things that we don't really joke with Chuks. The package registry enforces security on the package itself. The compiler also enforces security on the compiler itself. So when you publish a Chuks package, you need to list out the permissions that package needs or have access to. And what the compiler does, it kind of restricts that package to that permission. So if your package has a permission of, let's say, a file system, right, and under the hood your package is making a HTTP call, that will never work in Chuks, because you didn't define that your package will have access to HTTP. So security is down in the compiler level, right? So back to your question, Chuks RPC, we pushed it to the package level, and once it's out, you enjoy using it, because I don't like creating all those proto buffers, right? And in Chuks, you don't need to do that. With data type, you are good to go.
Thank you for answering my question. Kudos. Nice job.
All right.
Yeah. We are going to soon open contributions to Chuks, right? We just want to ensure that we get to the point where we are, in terms of security, we are very stable, so that we don't fall for the traps of what other package registries like the likes of NPM and the rest are falling for. You heard what recently happened to Axios.
Even Laravel last week. Laravel was
Laravel, we are trying to innovate and ensure that we build packages in a secure environment. And everybody on this call is welcome to contribute, build your tools, build your packages that will help you get anything done. So to move on the questions, we have one from David Isha. We'll go ahead to read the question. He says, from the website, I saw a benchmark. The Chuks HTTP bits go net/HTTP. That is for static hello world responses with zero IO, that's zero input output, but a real API does DB queries. Is there any benchmark with a real database like Postgres SQLite query instead of just HTTP hello world?
Yeah, so currently, no, right? And also, when it comes to IO operations, Chuks is also extremely fast. And in terms of the database part, that's one of the reasons why the database layer is inbuilt inside the compiler, because we needed to tune it to make it much more faster. Now, because the compiler is already in binary, that means your database layer is already in the binary form. So when you make a query or anything, it's extremely fast, right? So that is one of the reasons why we added the database in the compiler. So I think we'll also need to publish a benchmark for that, so that you can also see the metrics.
We really need to move on to just showing us how the environment is and compare it with Node.js. Just okay, Bimbo, you have a question. I think this will be the last question. Then we move on to the next stage. Bimbo, can you ask a question? Yeah.
All right. Yeah, hold on. This is really impressive. And yeah, my question is, you mentioned a whole lot of packages that is inbuilt. with Chuks, and like drivers like I think MongoDB, Postgres, MSSQL, and the likes. I want to ask, like, if I just want to use MongoDB, and do I when I if I install Chuks, and do I just have everything bundled it together, and from the standard library I could just import it? Because if I have everything bundled in together, and I don't want to use MongoDB, or I just want to use Postgres, and I have MSSQL and all the likes, because the final binary is too large because it's going to have a lot of thing together. Or I could just install the one that I just want to use without having to bother about every other.
Yeah, so in terms of the database, we only have the most used databases out there, like Postgres, Microsoft SQL, Oracle, MySQL, MongoDB, right? And the final binary is not that much compared to other languages. I mean, this binary that we're talking of, not any file, these zeros and ones, right? So it's not that much. It's not that much. You can check it out. So, and that is why we are building the package registry, right? So every other thing goes to the package registry. Do you get? And also open it up for other people to also build their own packages and deploy there and use, right? So, but the 92 to 95% of the things that you need to build a backend system, right, is already in Chuks. Unless you are now talking of integrations where you need maybe Redis to communicate with other services and stuff like that. You get all those things will be in the package registry. But the core things that you need to build a backend system, right, is there. I mean, it's a modern language, right?
Yeah.
And in this time and season, when you talk of backend is not just building, a CRUD app and stuff like that. Data, this is the AI race, right? So Chuks is also for the backend engineers and also for the data engineers, right? I think last 3 weeks I posted something on LinkedIn that you can now do data science in Chuks. So those are the part of the things that we are bringing in the next version release for Chuks. So as a data scientist, you can do data science. You can build classical machine learning in Chuks and stuff like that.
Thanks.
Okay. Somebody asked how is error handled in Chuks?
Yeah, I mean it's very, very smooth, and I borrowed that from Node.js, right? In Node.js you have the try, catch, and finally, do you get? So that is the same approach, that the same philosophy, because I think Node.js handles error very well compared to some other languages. So in Chuks, I kind of use that same philosophy. So in your try is where you write whatever you need to write. If there's an error, you can catch it. And in the final section is where you write any code that you want to be executed, whether the try was successful or you had any catch.
Okay, I believe that answers that. Yes, we can actually move to the next session. So let's have a little feel of the Chuks language in words. I think this will just take a couple of seconds, under maybe 2 minutes, and we are done. So I would share my screen just to show us a bit of comparison. Please let me know when you can see my screen. Yes, I might have to reshare because I'll be moving between screens. So let me reshare the entire screen. Yes. Great. So I have this screen in front of me, just VS Code. Let me align this here. So we'll do a bit of benchmark, right? So I already have Chuks installed. If you go to the official documentation of Chuks, I was checking out Go, but here, if you go to the official documentation of Chuks, right, you will see here the installation guideline, right? So there are various ways you can actually install Chuks, right? You can download the tar or GZ if you. Okay, go ahead, Emeka. You have something to say?
Yeah, I think the easiest way to get started with Choose is more like to install it. If you go to the home page, click on click there. So just copy this, right? So this code kind of dictates the operating system that you have, whether it's Windows, Mac, or Ubuntu or anything. So just copy it and run in your terminal. It installs Chuks for you.
Okay. I already have it installed, so it doesn't need. Can we all see my terminal?
Yes.
Yes.
So once you have that, all you just need to come is use the word Chuks, right? And you do that V, and you see the current version, which is Chuks version 0.08, right? Then you can also do Chuks, and press enter, and you see a bit of man files, that's help files and command that you can run. Most of the command you're going to be using is the new, the run, the watch, and the build command, right? Then you have other commands that can actually assist in upgrading, maintaining the Chuks file. So you can actually give that a try. So there are various ways you can actually write Chuks. Let me go to the VS Code. The first one is through the Chuks file, right? So you create your Chuks file, or you use your Chuks new project to create a new project. So here I will just do a quick run. If you look at my VS Code, you will find out that I have Node.js beside Chuks, and I have a couple of scripts that I've written. And this script is just the test to run a test to see how fast Chuks is compared to the likes of Node.js. So if you look at the benchmark, Emeka mentioned that Chuks is not on the level of Node.js, right? And also Chuks has another advantage over the likes of Node.js and the rest, because you can do what we call the AOT compile, which is ahead of time compile, and you can actually use it in your VM. VM here is just you run it, you understand, your build watch and running terminal for the purpose of development. So we are going to actually just do a quick test between Node.js and Chuks. We'll do the two. One is going to be in the VM, and the other one is going to be on the AOT compiler. So what do I have here? So on this page on my right, you can see I just have a simple Node.js server, HTTP server that just takes with 3 routes. I think the /, the status, and the JSON routes. We are very familiar with this for Node.js developers. And on the right, I have Chuks, also a Chuks server, HTTP server with the same exact 3 routes. But I'm going to be using one because of time. But before that, before I run the server, I just want to show us other things. In Node.js, we are very conversant with the console.log and other languages, but here we use print hello world. So once you write this, you can run it using Chuks run. So why this will work is because I already have this as a project. So I have a Chuks JSON, and in my Chuks JSON I've specified various commands that I use in running. But the command is to use Chuks run, then the Chuks file that you want to execute. So let's go back to this and let's continue. So I want to run this print hello world, a simple program, the usual ritual for every new language. So I just do Chuks run, and I navigate to where the file is. I think this is main.chuks, and I press enter, and you get hello world. So that's how Chuks runs out of the box. You can now have your other build commands, where you have your Chuks build, your Chuks run to run some certain scripts. So for example, if I want to use the Chuks JSON or the predefined scripts to run, I just use Chuks run. It still executes the same thing. Exactly. Running project entry in Chuks main, right? And this is because it was specified in the Chuks.json file. So that is how it's very easy to get Chuks up and running. So now that we have that, let's do a bit of the benchmarking. So I'm actually using Worker for HTTP benchmarking at this point. I know somebody asked a question about, we would like to use real world application to benchmark, use real database that has IO input and outputs to benchmark. But because of time, we are just going to use this simple HTTP server to benchmark the both applications. So I'm going to be actually starting the Node.js server first, and I will use that using the command node app.js to start the Node HTTP server. And I'm going to be using Chuks here, Chuks run to start the src/main.chuks to start the Chuks server. So we have both server. Let's remember the Chuks is starting on 9,000 and Node.js is on 3,000, which is the usual suspect. So what I'm going to do is right here, I have a tool called WRK. It's a very lightweight tool that we use in doing HTTP tests or benchmarking. So if you want to know more about this tool, this is it. It's a benchmarking tool. You can just install it your command line, and you can just fire a quick load test to your HTTP endpoint, and it gives you this type of output here. Let me increase my screen. It gives you this type of output, and what the output is it gives you the latency of each request, and it gives you the amount of requests it's able to process per second. So what T12 means here is we want to fire 12 thread. We want to keep 400 requests connected, and we want to run this within the space of 30 seconds, right? So we want to see how the bot is going to perform. So here, there are particular things that we are looking at. We are looking at actual performance, right? And we are also looking at the amount of load that each of these systems can actually, these languages can actually take. So on my right or my left, I'm going to fire that of Node. On my right, I'm going to fire that of Chuks. So I'm going to start with Node first. So I'm just going to copy this. I think I ran this sometime. Let's just go back and do this. Good. So here, on my right, I want to use 12 thread. I also want to fire about 1,000. I want to keep 1,200 HTTP request connection open. And I want to run this within the space of 30 seconds. And I want to see how this is respond. So if I click enter, so it's running the 30 seconds test. And at this, I can come here to my see this. So you can see that the load test is already happening. You can see that the terminal is moving, right? And we'll give that a bit of time. So I'm using, if you want to know the specification of my system, I'm actually using an M2, MacBook M2, 16 gig 512 laptop. So yes, it might look very smooth on my system, but you can also try it with your own system, because we're also trying to get benchmark from every system as we can. And you can do that from your system and share your findings in the Chuks community on ClearSet, which Emeka is going to introduce us to. So I think this has finished. And here we can see that we have an average latency of 21.21 microseconds. Yes, so we have a standard deviation. So this means based on the best latency, what is the difference between the best latency and the worst latency? That is what we mean, the standard deviation here. So we are seeing about a difference of 42.7 microseconds. And here the max, that's the fastest we got in terms of latency is 1.59 seconds. And the deviation is about 98.43. So we want to keep this under, this is supposed to be under 70% for the standard deviation in terms of latency for you to have a very optimal system. But you can see that Node is doing way above that, right? To the human eyes, it's insignificant, but when you have a lot of processes stacked on top of each other and you are losing about 42.75 ms, and you are only able to process about 1,005 requests within a second, then it begins to become very significant. So if you look at the request per second, it's able to do 1,005 requests at 449.95 requests, meaning this is the highest or the lowest request he was able to accept within a second. And the max he was able to accept within a second is this. And if you look at the summary, so the request is able to treat is 12.3 in 30 seconds, and he was able to transfer about 2.70 MB within the space of a second. So this is the summary with Node.js. Now let's compare that to what we have with Chuks. Permit me, let me just look for those commands so that I don't have to start firing it all over again. I will just change this to 9,000 because we are running Chuks on 9,000 here. So let's fire that same request with Chuks. Eyes on this terminal here. Should have 12,000 connections open. And yes, Chuks is actually running. So we should, in about 30 seconds, we should be seeing the summary of our request. So what is this? We are looking at, we're trying to look at how many number of requests is Chuks able to process within the second. What is the latency like? All right. Okay, so it's done. Yes, it's done, and we have our results. So for Chuks, if you look at the latency, we had about 5.05 microseconds average. We have about 29.497 microseconds as the deviation, and we have a max of about 740.64 microseconds as the max time it took, and we have a deviation of 99.14, and that is also above the accepted. Then if you are looking at the request per second is able to process, we have about 6,022K and request per second, which is like times 6 of what Node did. And we have a standard deviation of about 2,000 requests per second, and the max request we were able to treat per second was about 13,064, which brings it about 74% in terms of deviation. Now, if you look at the total request in 30 seconds, Node.js was able to fire about, this is 373,000. Chuks was able to fire about, this is 2,188,000 requests in 30 seconds. And the total read it got was about 133 MB, and Node was able to give us about 81. So if you look at it, Node and Chuks are actually not in the same class, which is because of the underlying principles and what Chuks was built on, which Emeka is going to share shortly before we close. And we're able to actually process and transfer 4.4 MB. Request per second was about 72,000, while Node was giving us that. Now, if you notice, this is still on the VM. We've not actually treated the AOT, so that's ahead of time compilation. So we are actually just running this script maybe for the purpose of development. We still need to see what happens to the benchmark when we run the VM, right? So, or run the build, like we always know it. So you know that for Node.js, we run build, but Node.js will never give you binaries. You just have a build file of minified JSON that you run, and the difference is not that much between what you get during your development time. But for Chuks gives you a binary that you can take, and you don't need to have any other dependency to run it. So I'll show you an example of that. Now I'm going to close this. I'm going to close this. If you look at the file here, you will see that I've compiled a Chuks compute or Chuks main bin, right? Now I'm going to delete this, and I'm going to show us how we can actually build the binary file. So what I'll just come here is I'm just going to run or before I do that, let's look at this. Now you have the Chuks build project. Right now, Chuks build project is actually going to run a build for main, and the command is running is Chuks build this, right? So rather than running this script, I'm actually going to run this command directly in my terminal so that it creates the main build I just delete, the main binary I just delete. So I'm going to say Chuks build src. I'm trying to navigate to the directory and I want to build main.chuks. So the build should actually give us that file I just deleted, and I'm going to, so I'm trying to, this is how we do the ahead of time compiling. Now I want to create a binary out of everything I've done here, right? And you can see that Chuks was able to give us that binary. Now with this binary, it's just as simple as taking this binary file and putting on your server and just doing this. Go to the location of the binary, which for me is going to be, I want to do, I don't need CD, I would do build, because I think I'm at the home directory, yes, build, and I would do main.chuks.bin, which is the binary file. I want to be sure of my spelling. Yes, main.chuks.bin. Now, with no extra command or manager or anything, you just come here and you just press enter and your software starts running automatically. All right. Now, I'm going to split this terminal here. I'll split it horizontally. So on the left, you have Node.js. On the right, at the top, you have Chuks VM. And on the bottom here, we have Chuks AOT, meaning we don't run our VM in production. It's a no-no. What we run is our build, right? So we want to see if we build Chuks and we run it on production with that's the bin, we run the bin on production, what's the benchmark going to be like? Right. So I'm still going to take that same worker, this same command I ran here, and I'm going to fire it again, and we see yes, 9,000. Let me check the ports. So we have 9,000 here. Look how it's 9,000. Okay, good. And we click on enter. So it's running the command, right? So here it's not showing any this thing because we're actually running the build file. So everything is happening within that binary, except you have a package or a runtime manager like PM2 that you're using to monitor the logs. You just see this statically. Now let's see, it's still running. Would wait a bit for 30 seconds for we to get very, very good. So we have our output. Now let's see what the binary was able to do. Yes, so the binary did 30 seconds test. We have a latency of 1.4 microseconds, deviation of 1.31. You can see that the deviation here was very little, and the max we got was max latency we got was 56 microseconds, and here we have 92.93. We were able to do 12,000 requests per second, where we had a deviation of about 4.94 K, and the max we were able to treat, that's the max number of requests per second we were able to treat, was 56,000 requests. And yeah, we got this. So if you compare the what do you call it? That's the request we're able to treat within a second. You'll see that we got 8 times 2 of what we did for the VM. Now the VM, which is our development time environment, we had 2 million here. For Node, we had 373,000. But on production, we are seeing Chuks doing 4,338,000 requests in 30 seconds. That's a lot, right? I don't even think Java can do this. We're still going to look at C#. We're still going to look at C# because we've not benchmarked against C#. We're going to compare C#. So if you look at these figures, you find out that this put Chuks in the level of Go, Rust, and the rest. And Taiwo asked a very fantastic question. He said he sees that Chuks is just like go with question marks and this thing. And I will leave Emeka to answer that question. But what you look at this is the problem between performance and adoption has been a very big problem for engineers, right? If you want to go towards performance systems that are fully optimized that you're not talking of the like of C, you're talking of the like of C++, these are going to give you very close to low level processing as you can get. But the problem with this is, have anybody here tried writing C++ or try writing Go or try writing Rust? I want to know how your experience is with writing those languages. It's like chewing glass. Those languages are very difficult to write. If I give you a book on C, I give you a book on Rust to write, I don't think you will finish it under 1 year. So what we are looking at to do is to bring that expressiveness we have with the language like TypeScript, expressiveness we have with the languages like JavaScript or Python, that expressiveness is what makes most programmers like us stick to those languages. Now, if you have a small idea and you want to bootstrap this idea and you want to test your proof of concept, I don't see anybody running to Java to go and pick up Java. I don't see anybody running to Rust to go and pick up Rust. What do you want to do? You want to, apologies for that, you want to pick up a language that can let you express your thoughts, right? And with less concerns for all this, and just want to run it. So we want to bring that same expressiveness into the likes of C, the likes of Go, likes of Rust, and the rest. And that is where I think, for me, I think Chuks do some kind of justice, giving you the ability to be expressive. You can see the syntax here. Very easy to read, very straightforward. Gives you, if you've done TypeScript, you've done even Java, right? You've done Laravel, you fall in love with the way the language is expressive, right? But go and look at Go and look at Rust, go and look at the language. Even as some programmers, if you show them those languages, they are still confused as to what they are saying. So yes, it's a merge between the both. So I think with this is just to give you that foundation to say, this is what we've done, right? We are not claiming to be the best programming language out there, no, but one of the things we discovered and the lie that was told to us was that don't reinvent the wheel. But the truth about reinventing the wheel is what has brought about innovation, right? Why did Elon Musk decided that he wants to create rockets if they've been creating rockets? He decided to recreate rockets because he believed that rockets can be better than what they were, right? If everybody say, oh, rocket has been created, then there is no need to reinvent the wheel again, we would not have had reusable rockets. So reinventing the wheel is where innovation actually starts from. And that is why we always ask ourselves, what can we do better to make what we have better our lives, right? And I'm going to show you a couple of pictures. How many of us know this person? This is Dennis Ritchie, the inventor of C, right? This is who? Linus Torvald, the inventor of Git, the inventor of Linux. This is who? Tim Berners-Lee, the inventor of internet. Many of us engineers might not know these three people here. We might not know them. But without these three people, 70% or 90% of programming today would have been difficult. So we are used to people going out there, creating fintech applications, collecting funding and the rest. But there are people who actually engineer the fundamentals, they engineer the foundation. And I think that is what Chuks is trying to do, redefine that foundation. And one of the good things that make Chuks interesting to me is that because it is Nigerians like us that is building this thing. We've been using foreign imported languages. We've been using foreign tools that are not even owned by Africans. But this is ideas coming. We still have a lot of ideas like this. I still have a lot of friends like this that are building remarkable things that are Nigerian first, right? So it's just a food for thought. What do you think? Which direction do you think Chuks can go? And what kind of problem do you think Chuks can actually solve? These are the questions we are going to be talking about in the Chuks community. These are things that we're going to be experimenting. How can we bring in Chuks to begin to solve real world problems? And I think Israel David just mentioned one way we can actually do that, right? So this is a simple test that you can run with Chuks. We need your feedback. We need both positive, both negative feedback. Please do not only just look at the good side. Break the system. Let's find the issues, because at this fundamental level is the only time we have to get it right. If we don't get it right here, we'll be falling into the trap of the likes of Node.js, Laravel, Python, and the rest, right? But at this fundamental level, if we can build a solid structure, I believe we can create something important. At this point, I want to take it back to Chukwuemeka for any final notes before we bring the session to a close. Emeka, you have the floor.
All right. Yeah. Thank you so much. Thank you very much, David. And thank you everyone for joining this amazing event. Felix, your hand is up.
Yeah, thank you so much for doing this. This is actually very great. And seeing that it's also in Nigerian technology, so I think it's something every Nigerian should adopt and also think of ways to improve on, right? So I was going to ask a follow-up question to all that David has said. I just typed it in the chat too. Is Chuks thinking about merging both front-end and back-end together?
No. So what Chuks is doing, I won't say trying to do, because we've seen it is working, is having one language, right, for both your backend and data, right? And because Chuks also supports functional programming OOP, and you can also use it as a scripting language, right? I think someone just asked now whether you can use it for automation, right? So because you can use it as a scripting language too, right? Automation, you can also use that means you can also use it for automation. The same way you write your Python scripts, you can just write your Chuks code and run it. And the good thing is you can run a single Chuks file, just as David just showed us here, right? And you can also run the entire project, right? So imagine you have I don't think you can do that in Java. You can't run a single Java file. You need to compile it, you need to build the entire project. So Chuks gives you that flavor that you get from the likes of Python, right? The likes of Node.js. Just create a single file and run it. So anything backend, anything data, anything automation, AI, because this is the modern age. This is the things that we have right now, and Chuks is built for that. No front end. One of the things that we are trying to build is the community around this, right? And this is, like I mentioned, this is the very first Chuks Forge, right? The previous one was the Forge release Forge, but this is the very first Chuks Forge. And with this, we are also trying to build a community around it. We are using Clayset. Clayset is a social networking app for growth. We are using it as our platform for our community, right? And I will really be happy if every one of us who is in this call check out Clayset, download it. I'll just paste the link here. Clayset.com. Right, so check out Clayset, download the app, depending on the platform you are using, whether Android or iOS, right? So in Clayset, once you are in, check on the community section. You will see Chuks community there, right? Join is an open community, right? So join. If you have any question, if you have any contribution, anything about software engineering regarding to Chuks, right, you can drop you can drop it there, and we can always brainstorm and help make Chuks a much more better language. This is just the beginning, like I mentioned.
Yeah. So yes, I guess that's it. I think we've been able to take all questions. Kufri, we might not be able to take additional questions because of time. You can drop your question in the comment section. And I think Chukwemeka will be able to respond to you directly via anywhere he can meet you. So we know that there's a lot of conversations that we might need, a lot of topics we might want to discuss. We are looking at support for the language and the rest. And that is why we are begging on everybody here as the early joiners and partakers on this project, right? We need feedback from the community. We are going to need dev advocates that will push the language, put it to real world test and the rest. And come, let's build something very fantastic. It is actually, it is actually open source. Taiwo, it is actually open source. We are going to be publishing the repository so that you can fork it, you can do everything that you can do with it. But that is going to be communicated. And once that is communicated, you receive an email as to how you can join. So because we are trying to look out for security at this point in time, we are trying to, you have to be in the ClickSet community for you to be able to actually contribute to it. Because one of the issues we find with the likes of NPM and co was because they could not control the contributors that they had. They had rogue people putting in, Trojans into a lot of the packages, the language, and they were now exploiting. We now see them exploiting all this vulnerability. Imagine there's a vulnerability that has been sleeping in Axios for over 10 years and nobody knew, right? So that is why we want to use the ClickSet community to understand who are these contributors, right? What the impact they want to bring in and be able to at least monitor the contribution. So you will get a message. We have your emails. You get a message on that, and you should be able to then contribute to the project. So I want to thank everybody for joining. I can see Mata, I can see Felix, I can see Chigoke, I can see Dokas, I can see Taiwo. I know it's the weekend, very difficult to take time to actually look at this, but it also shows that we are Pan-African, right? We are trying to support homegrown technology rather than always exporting or importing technologies, foreign technologies. And I believe we will see more of this because we have wonderful brain on this call. So without further ado, please look at the documentation, download Chuks, break the language, give us feedback, and we'll be happy to work with you. Good day and God bless. Bye. Thank you.
Thank you everyone for joining. Please download the ClickSet app and register and also join the community. All right. Thank you all.